Actually, by using the lecture material, you can see this equivalence, right? Because, I mean, if we define this P like this addition, in terms of the divisor equivalence, we know the existence of a function z such that P plus Q is equal to R plus O plus Z. So P plus Q minus R minus O is exactly Z, so Z inverse in the Riemann space of this divisor. And conversely, if this is not trivial, we know that this is a degree 0 divisor, right? P plus Q minus R minus O is 0 divisor, and its Riemann space is not trivial. So we have the corollary which tells us this is going to be principal divisor. So there exists a function z, P plus Q, R minus O, minus R minus O, is exactly the principal divisor of z. So automatically we can derive the elliptic curve addition. And to be able to see that this vector space is spanned by like the Riemann space spanned by the function which relates the rational places P and Q. Indeed, like we have this inclusion, right? For the other way around, first let me suppose that P and Q are different from identity. And let me consider this functions times the Riemann space P plus Q minus R minus RO. And let me use the property here, which was given as exercise. This is going to be S minus R, where the S is the third intersection point of the line MPQ with the elliptic curve E, or with the elliptic function field E. This can also happen when this third point is the identity. You can observe it. And in this case, like because of this equality, we know that it has positive dimension. So this Riemann space should have positive dimension. But S is the rational point. So by this fact, we can conclude that S is indeed equal to R. Then the Riemann space S minus R is equal to FQ. So this is the base field in our function field. So automatically we can see that this Riemann space is spanned by this function. In the case of P and Q is not the identity point. If P is the identity point, then P plus Q is equal to Q. And Riemann space P plus Q minus R minus O is going to be Riemann space of Q minus R. This is non-trivial by the assumption, so it follows that R equal to Q, again, by the fact that if this is non-trivial space, these rational places should be the same. So R indeed equal to P plus Q. In this case, this Riemann space spanned by the constant, a non-zero constant, but in general we can take it 1. And in the setting, we set FPQ as 1. again, we can see this equality. And you can also verify that what happens like Q equal to O similarly. And by using this observation now, we will give a bit general result. For an integer n, which is bigger than or equal to 1, by the NP, what I mean is P plus P, like the n sums of the rational place P. If this is an n torsion point, so that means if n is the integer, actually for the torsion point, n should be the smallest integer, but if we have such an integer where this n sums is the identity, if and only if L of NP minus N of O, so here, let me denote this summand by N, but here what I mean, the divisors NP and NO. In this case, this vector space spanned by the product of the functions which relates P with their multiples. So here we have the product. By using the previous lemma and by using the properties we considered so far, indeed you can prove this equality. It's just a matter of computation. And the last theorem we need, indeed, this is the kind of functional field version for the Abel-Jacobi theorem for the elliptic curves, which tells us if we have a divisor in the form of RO plus AIPI I from 1 to n minus 1 of degree 0, we can get for the degree 0 characterization, we have the characterization when it is principal or not. This is going to be another characterization. We say that this degree 0 divisor is principal if and only if this sum is equal to O. So here what we mean, again, the elliptic curve addition. So here we consider the addition on the set of rational points. Here we are considering the addition on divisors. And if D is principal, we know that D is the form of for some function. If indeed this function is in the form of the product f of P and Q. By the previous theorem, is the product of the form Fp and Q. And now let me turn back to the OP star structure, like which we said in the beginning. But in this structure, I will fix these intuples as rational places. And then if this is the case, OP star is generated by the functions if PQ where PQ is a rational place in P. Consequently, the lattice L of P, like delta P, our function, elliptic function fit lattice, is generated by the vectors of the form P plus Q minus R minus O, where P plus Q is exactly equal to R. So what we mean is that like the images is going to be like 1, 1, minus 1, minus 1, and 0 for the other entries, or like depending this P and Q and R located in this intuple. And the sketch of the proof, actually it uses like the previous theorem. Without loss of generality, we may suppose that these AIs, like the coefficients of these PIs, are positive. So we are talking about also kind of like the positive summands. And for a place P in this n tuple, in the set of rational places, and for an integer K, we will set, like just to simplify the notation, we will denote this product of the function which relates P and their K summands by Tk of P. If Aj is negative, by the way, like I will elaborate this assumption. If this is negative, Kj be the point order. Let Kj be the order of the rational place Pj. And by theorem 2.2, the divisor of like the principal divisor of this product, just by the computation, like compute the principal divisor of this product, so that means we will compute the principal divisors of the each components, is going to be minus Kj Pj plus K times O. So in this case, 1 over Tkj of Pj, like this function for the place Pj, to the L times the Riemann row space of D is going to be L of D prime, where the D prime is in the form of R minus Lkj O plus AI Pi Aj L Kj Pj is different from band J, and this part is positive for sufficiently large L. And moreover, if D prime is principal, if and only if D is principal divisor, right? You can again observe this by looking at this equation. And the sum of the rational points Ai, Pi, and Aj plus Lkj, this again, it denotes the like Ai summands or Aj plus LKJ summands of the places Pi and Pj is equal to Ai Pi. And now let me write D as R times O, Q1, Q2 up to Qt. And we will allow the repetitions like this. Some of the Qis and the Qjs are might be the same. And T is equal to minus R. If we put as I as Qt minus I plus Qt minus I plus 1 up to Qt, and if you consider Ti as, like again, actually, like we use the divisor notation, like we are working with the principal divisor. What they mean in this paper, they essentially mean the same thing. Here they consider the corresponding rational places. Let me take as the same. So in this case, with respect to these rational places or the rational points, if we set a function which relates Qt, like the product of the functions which relates Qti and Tj's, we can see that 1 over f L of D is indeed Riemann-Roch space of minus O plus Tt minus 1. And then just like making the computations again, if this is like the principle, if and only if T minus 1 is exactly O and Tt minus O indeed gives us this equality just by checking the Tt minus O in this definition. And furthermore, if O plus Tt minus 1 is principal, if and only if 1 over f L of D by the choice of this f is spanned by the constant 1, so L of D is indeed spanned by f. And now for the rest of the statement, like for each function f of p and q, we know that it has support of principal divisor is a subset of p, so that means f of pq in OP star. And indeed, like we can observe that this OP star is the union of the Riemann-Roch spaces of L of D different from the zero vector, where the runs through the all principal divisors with the support in P. Please think about this equality. Then we can see that L of D is the span of the products of the functions of the form FPQ, and this completes the proof. And now we are ready to say what are the minimums? What is the minimum distance of the function field lattice, elliptic function field lattice? And finally, we will finish it by proving that this is well-rounded. So that means it is indeed generated by its minimal vectors.